Hello, everyone, and welcome to the Spiceworks Ziv Davis Partner Webinar. I'm David Solis from the community, and I'll be your moderator for today's session, which is being brought to you by Trilio. And today we'll be discussing recovering and porting applications in the fast-paced DevOps world. Before we hand it over to our expert, Kevin Jackson, I'll cover a few reminders about our session today. First of all, this session is being recorded, so if you step away or miss any part of today's session, you'll receive an email with a link to view it on demand at your convenience. Also, Trilio's provided additional resource content for this session, so check out the resources section located right underneath the slides for some downloads. We'll also be taking your questions for a live Q&A session with Kevin. You can get those in using the Q&A widget on your screen. Submit those and they'll queue up on our side, and we'll get to as many of those before we finish. And if we don't get to all the questions, we can follow up with you after today. Finally, we do invite everyone to jump into the attendee chat. You can do that using the orange chat icon button at the bottom of the screen, second from the right. And you can start a conversation with your fellow webinar attendees. A reminder that our webinar chat does follow our Spiceworks community guidelines, so while chatting, please keep things fun and professional. With that, I'll hand it over to Kevin Jackson, Senior Solutions Architect at Trilio. Kevin is responsible for customer and partner engagement in the EMEA region, helping enterprises meet their data protection and DR requirements. So with that, Kevin, I'll let you get started.
Yeah, hi everyone, and thanks. As David said, I'm Kevin Jackson, one of Trilio's senior solution architects. We have a number of them dotted around the globe to help you, and I do have a truly wonderful job of taking people through the fantastic world of Trilio. And I might as well take the liberty of introducing to my dog Nala, who will no doubt make herself known during today's webinar. If she does, she's just shown her enthusiasm for what you can achieve when you have the right data protection tool in place. So just treat that as bonus audio content you don't normally get during a webinar. And if she doesn't, let's pretend that chat never happened. So today I'll be taking you through how the world of backup and recovery is no longer relegated to a function of back-end IT, but is now firmly a core feature of a fast-paced DevOps world, allowing you to easily protect, recover, port applications from one environment to another using Trilio Vault for Kubernetes. We've always seen that data protection is far more than just simple backup and recovery. So during this session, I'll introduce you to Trilio. I'll do a little reminiscing of IT over the years and how backup and recovery has evolved from a back-end IT function to being core to DevOps pipelines. And I'll take you through a few scenarios showing that data protection begins with the developer. Sorry, developers, it does all begin with you. And I'll finally show you a demo of porting an application from Openshift on-prem to GKE using Trilio. So first up, of course, who are Trilio and how do we help enterprises protect and migrate their applications and data in the cloud? Well, we obviously recognize that there's a huge disconnect between traditional data protection products and how clouds are utilized. Across our portfolio, we have 6 core tenets that you should expect to find in a mature cloud data protection product. First, look at that, there's enthusiasm if you can hear my dog. First, your data protection tool should be agentless. Agentless allows administrators of the cloud to do what they do best and concentrate on ensuring the uptime of that cloud platform. But agentless also ensures users don't have to think of that extra piece of software every time they deploy to the cloud. The cloud platform itself should perform the protection of the containers and VMs, all the things that run inside of the cloud, and not be an afterthought of the container or VM itself. Secondly, it should be non-disruptive. Non-disruptive data protection means we're doing a job. We're doing it well, and you shouldn't notice we're doing it. We want to get out of the way as quickly as possible and cause the least amount of friction to your workflow. We know there's a reason why you chose these cloud platforms. The last thing you want to do is put in some heavyweight software in there that gets in the way of how you want to work. Multi-tenant, multi-cluster, and self-service. I like to bring these features together. As we're deployed as a feature of the cloud platform, we're data protection as a service for your users. So it's all about the users. Can you really call it a cloud if you're raising help desk tickets to perform a particular task? So at what point did it become acceptable for restoring data through tickets and then waiting, for 24 hours before you get access to your own data? Obviously, it didn't. It was never acceptable. You own your applications, you own your data, you own how recovery occurs in the cloud. It allows you to just get on with your work. Scalable. Look, cloud is all about scale. To administrators, scale means ensuring enough resources and availability to the users of the platform. Fully integrated tools such as those from Twilio, of course, allow administrators to scale all their cloud services easily and not forget about the other thing called backup. Scale also means users can scale their applications without even a second thought of having to ensure that the apps continue to be protected. And lastly, an open universal backup schema. Why is this important? Well, it's an often overlooked part of the backup requirements, basically how your backups are stored. Twilio uses open source formats for its backups. Why, is that an important feature? Well, an obvious one is the format we use is recognized as an efficient data format, allowing Twilio to produce incremental backups at source. Why would we reinvent the wheel? Why would we choose something else? We don't need to. This incremental backup at source cuts down on data transfers and, of course, reduces storage costs without costly vendor-specific space-saving techniques that need to be applied at the target after you've sent all the data over there. But the thing is, it's we also have an open format because it allows you to always get access to your data, regardless of what happens to the vendor that created that backup, that file. It means you no longer have to keep that important CD with that backup software that was compatible with Windows NT and keep all that data for 20 years and being able to access it. And you know what? We do all of this across the whole portfolio at Twilio. So whilst people's cloud journeys are more than just Kubernetes, we're going to pay special attention to it during today's session. Our Twilio Vault for Kubernetes product, or TVK as the cool kids call it, gives you an easy to install operator that works on any CNCF Kubernetes distribution. It provides you with some new custom resource definitions to protect and migrate and port your applications and workloads, driven using either this multi-user interface that you can see in front of you. That's what you get out of the box from Twilio, allowing you to access multiple clusters, multiple Kubernetes clusters. Or you may prefer to use the command line, continue to use your kubectl, your OC, whatever you prefer to use. You can continue to use that, but now just saying, hey, protect my workloads. Or you can have this as part of your pipelines, your CI/CD workflows. You can invoke Twilio just as another event-driven part of that workflow. And we'll protect any data in persistent volumes presented through the container storage interface. And we can store those backups on any storage presented as S3 buckets or NFS exports. And that S3 can be on-prem S3, could be Ceph S3, for example, could be your favorite vendor's interpretation of S3, or could be genuine Amazon AWS 3. We will store our backups and protect your applications and write them out to wherever you need them to reside. You are in full control. And we don't care where you run your clouds. Well, I mean, we do care. We have a fantastic, support team that genuinely care about your data and where you, the importance of your data to you as well. But what I mean here is that you can run your Kubernetes cluster wherever you like and have Twilio installed wherever you like, whether that's on-prem, off-prem, public cloud, offline air-gapped-based environments. You own your backups. It's all about you having complete control over your applications and the protection of and where that needs to be recovered to. And lastly, we don't dictate how you package or operate your application deployments. We're very proud that we conform to all the standards, high standards, open standards expected when backing up Helm applications, for example. We don't take shortcuts here. We back up, say, the Helm charts, the revisions of those Helm releases, so you can recover that Helm application wherever you need that to be recovered and continue your journey using Helm on that recovered application. Same for operators, obviously a variation on packaging and application management, back up the CRDs as part of those operator-based deployments and have that protected as part of your overall protection of your workloads. And of course, we can identify the apps, resources, and data by labels, multiple labels, and back them up, or just take a step back and give you the ability to protect complete namespaces and clusters and multiple namespaces as part of your backups. So what this means is that we understand how you work with Kubernetes and what you expect of a data protection tool designed for Kubernetes. We protect workloads in a way that works with the user's workflows and how they consume Kubernetes so they can recover their apps and data back to the same cluster or any CNCF Kubernetes cluster that has our TVK operator installed. So the path to cloud native. Let's take a look at the journey. This would have been the part where the dreamy music and the montage would begin as I take you back through the time of IT, but marketing budget didn't stretch for this webinar for today. So instead, we've got just the presentations. So in the beginning, just after humans discovered fire, came bare metal. Life was easy. You could walk into a data center, literally point at that important email server, the file server, and you can tell they were important. They had sticky notes on the front saying, or some kind of threat if you power these machines off. Then as servers became too powerful for their own good, for argument's sake, thanks to shrinking chips, virtualization was born. And in the 90s, VMware found out how to virtualize the x86 chip. Yes, not only am I old enough to know what Windows NT is, and certainly floppy disks used to actually install that damn thing, I was also an adult at the time when virtualization became cool and trendy, and VMware created this great product. Whilst you can no longer point with your fingers in the data center where that file server was, or that important email server, you could certainly point with your mouse. You knew that file server or that email server was on that server or that server over there. But life was still simple. It was just more efficient. Then as we approached the noughties, someone thought it was a good idea to do away with the idea of pointing and clicking with a mouse, and let machines decide where to run your workloads instead, and give people the ability to treat everything as code. The cloud made life scalable and flexible, but we're still a nagging problem. When you scale to hundreds of web servers, you are still making virtual copies of the hardware, the virtual CPU, the virtual RAM, the virtual NICs, the virtual everything. All you wanted to do was serve your GeoCities web page. And if you don't know what GeoCities is, please just go Google. Now, cloud native takes this notion further into the realms of efficiencies. So let's look at the world of virtualization again. And compare that to today's modern world of cloud native. So virtualization was, like we just said, was where you knew that given your file server, that all, 64 cores, half terabyte of RAM was a little overkill. And to be fair, your data center had limited floor space. There's only so many physical machines you can get into a room. Now, compare that to cloud native, where we now remove the hypervisor. Instead, workloads run as containers, basically C group based processors running just the code and libraries it needs to function, allowing you to autoscale to your heart's content, leading to highly orchestrated, scalable environments. Everybody's happy. The problem, though, for data protection becomes a lot clearer. You now have parts of your application broken down into much smaller parts and functions, basically strewn across many servers that dynamically shift or move as your application auto scales. So relying on traditional legacy management of these environments sees an efficient cloud native world becoming severely impacted, and decision making of how to effectively use your new cloud environment gets skewed. So backup services of old that you relied on several times a year, either knowingly or no, not so much, no longer function effectively in modern cloud and cloud native environments. The idea of backing up a Kubernetes cluster using an agent run on that bare metal server seemed okay until you wanted to recover a certain aspect of that Kubernetes deployment. It could be a persistent volume. You need that persistent volume back into that developer one namespace and attach it to that Cassandra pod. You couldn't do that if you're treating the backup from from an infrastructure point of view. So let's take a quick look at a traditional backup using an agent-based solution. Here we have a VM. So here's a VM. It's got an agent running in there. It could be a container with a sidecar to back up this container of its files and any disks that are associated with this. And essentially, this is a world where these VMs would have to talk to the mothership, the backup controller, over the virtual network onto the physical network, and it's the backup controller that ultimately would have the job of organizing the storage and the backup of those particular workloads. Now, this is all well and good. Obviously, it's very successful. It's used, the world over. However, in a cloud world, this is kind of weird because you've got this place where you own your applications and your data, but you don't own this. Somebody with a higher privilege, somebody with a different job title owns that backup controller, and ultimately, weirdly, they own your data on that backup storage. The restore doesn't make things any easier in a cloud-based world when you look at agents. And so this is a world where there are multiple steps. You end up having to phone up again, this higher privileged user that gets access to your data, and then somehow there has to have some kind of coordination human to human in order to recover that particular data and make sure it goes back to the right place. Now, we recognize that this process is not sustainable nor efficient. So we have tools that natively integrate into OpenStack and into Kubernetes. And we provide multiple ways to use these services, either using the user interface natively as part of those platforms. You can use the the command line tools, however you need to, and we back up the data and the metadata of those particular workloads. And so what this means is it allows us to, or allows you to very effectively now take advantage of a tool that was historically relegated to the deep, dark, depths of IT. And then it thrust it into a world where you now have complete control over your data and the recovery of your data using processes and a workflow that suits how you want to work on these particular platforms. So let's look at what we call the day 0, 1, 2 challenges. In other words, we're talking from development all the way up to operations and into production. So, the reason why a data protection tool has to evolve to work with the cloud is that it now has to work across multiple disciplines and teams. And so first of all, let's look at those typical reorganized teams. So I introduce you to into a few people here. And so what this is we've got 4 people and their roles. I don't know them personally. I'm sure they're all lovely people to work with. But essentially what we've got here is we've got development on the left. We've got ops on the right. And almost sounded like I'm breaking into a scene from Reservoir Dogs and I'm about to sing a tune, but stuck in the middle, we have the cloud platform and environments that they're all equally responsible for. Certainly have a reason of making sure that everything is running as it should. So first we have Lisa. Lisa's obviously responsibility. She's a developer. Her responsibility, of course, is to write the code, build the apps, test the application. In other words, make sure that code is production ready. Then we have Brian. Brian works very closely with Lisa from the DevOps, GitOps side of things. So he's an SRE. He has to ensure that app that Lisa has created runs successfully. And so he has to make sure that the apps are kept running and are running as expected as this gets promoted all the way through into production. Then we have Rob on the ops side of the SRE fence. So he ensures basically the platform and the clusters are all operational. His care is disaster recovery. He needs to make sure that the tools and the environment are all running as they should. And if they're not, we've got Jane who will tell him off. Jane is the IT director. Obviously, she has the bigger role to play in making sure that everything works from start to finish. But of course, her role is more of a business continuity and making sure that what gets deployed, what is running in the environment is of course making that business money. So the evolution. So naturally, backup tools were used for backup and recovery, and we like to see that as day 2 side of things. Day 2 essentially assumes applications are deployed and need protection. Rob and Jane have always assumed responsibility here, of course. However, we're missing the work that goes up to this point. So day 0 is development, where there's a need to automate code check-ins against production data that Lisa has developed. With Twilio, you can orchestrate the provisioning of scrubbed production data, for example. So the developers have access to good quality data and accurate data as part of the development life cycles. And I'll show you how that works shortly. Day 1 is the GitOps. It's the maturity of the tools, and it's about managing the infrastructure through code. So using the same techniques, from the development world, and obviously applying that to the operational world. So both Rob and Brian have a hand in this, and they need to make sure that the tools and the platform are equally available as part of this. But when you get into the world of, say, a GitOps, and you have tools like Twilio installed, you get the ability to manage and recover from configuration drift that may occur in the environment. So when we have Twilio Vault for Kubernetes installed into a development world where you have to take apps from one environment, promote them through from test to staging into production, you can use something like a GitHub runner, so that when, say, Lisa checks in code, data can be made available from other deployed environments and deployed into dev for CI/CD testing. So in other words, you can have orchestrated processes just because of our operator being there as part of your Kubernetes platform, which can take data from live production environment that's safely stored as a backup. We can recover that to wherever you need it to be, apply some transformations to that data if needed. And then that gives you the trust and assurances that you've got good quality data available as part of those tests. And of course, you can bring that further back into a world which will satisfy the likes of Lisa. So it makes sure that the data is genuine data that she can do her performance and her application tests against. So that's day zero challenge, accepted and accomplished through Twilio Vault for Kubernetes, because Lisa now has access to all that data she was crying out for, rather than the test data and the small database she had access to. But we're not stopping there. The team have to support multiple environments, on-prem to off-prem. Twilio doesn't limit where that data comes from or where it gets deployed to, giving your developers the ability to test their applications with appropriate data onto appropriate infrastructure or clouds, obviously is a core design principle of Twilio. So this is a day one kind of scenario where we see a maturing development process getting code into production. That's where we need to obviously end up. Here's another example of a typical code deploy. And again, we can assume some kind of event-driven GitHub runner type approach. So this is a world where, code gets checked in to a source code repository, and some action can occur and some trigger can be performed. And in this case, a trigger to make a backup of that environment. The core principle here is we're about to make a change, so therefore we should protect that environment. So in the event of anything going wrong, we can roll back. So code will get deployed into this environment and everything is all good. And it's all good until it's not. If anything goes wrong, then we can auto remediate, or you can have some kind of process or flag which will send a message to the help desk to say, go and recover this particular environment. In either case, what we've got here is a orchestrated flow, very easy to implement with Twilio Vault for Kubernetes. And then it gives you this workflow where you can certainly have a backout rather than always having to think of forward fixing. But as I said before, day one is also about the maturity of those workflows. As the cloud matures, there's a growing number of platform and applications to manage, code deployed to various repositories and tools to use as part of these particular workflow. And it's obviously critical to protect those tools and those self-hosted repositories, of course. But don't forget that Twilio is aware of your application. If we're able to back it up and have the assurances that we can do a recovery of your application, we certainly know all about the makeup of your application. And so we can discover what makes up the metadata of your app. So if only any unwanted drift occurs between the point in time that you deployed to ongoing operations, it might be a few days later, you can report and take action if there are configuration changes. They might be manual changes, it might be some unauthorized change, but you can go through and see why things have changed and potentially see who has changed that data. Now, I'm not saying I advocate, a witch hunt, but we can certainly give you the tools if you decide to go down that particular path. Now, day two is traditionally where backup has lived for decades. It's the afterthought because, I don't know, some auditors, were going to impose some fines on you because you didn't have the ability to go back and recover some data. All that embarrassing downtime made you think twice of thinking about, that backup is just insurance. But here's an unfortunate scenario in this day and age where we talk of ransomware and malware. So let's first look at the important aspect to ransomware, the fact that the backup software itself, or the backups, are a target for infection. So in this world, we've got an infected app. I don't know how bad this app is or what it does, but it certainly turns your world pink. I have no nothing against the color pink. It certainly just doesn't match the rest of this environment. And so in this world, everybody knows that to recover from ransomware or malware, the cast iron guarantee is pulling back from backups. That's just absolutely well known. But in this case, the malware also has identified that the backups exist, and the backups have been also infected. So this is a scenario here where we've got a world where backups do exist. They know the fact that they can do a recovery from backups, which is great, until they realize that that malware that was injected into the backups obviously has now just reinfected the environment. So at this point, whilst they got away from working out how to create a Bitcoin wallet in the first place, they're now back into the world of scrambling and doing some Googling around to work out how to actually now create that Bitcoin wallet to actually pay that ransom. Now, contrast that to a world where we've got the likes of Twilio Vault for Kubernetes installed. The difference here is obviously we recognize the importance of your data, and we're able to mark them as immutable and encrypted. So why immutable? Well, your backups should always ensure your recovery. We just talked about this. Nobody should be able to make any changes or alter them. This is your get out of jail free card, and it should work every single time. Why encrypted? Well, encryption obviously doesn't stop backups from being encrypted again. There's malware out there that will encrypt your backups. But that's what immutability does. It will protect you from those unauthorized changes. But what encryption does is it prevents or it makes sure that your backups are not the weakest link when it comes to stealing data and making sure data, is leaving your environment. So again, a secondary campaign of ransomware is extortion. People have got access to your data, and so they will try and squeeze some money out of you by publicly shaming you. So again, by having your data encrypted and you own those encryption keys, obviously is vitally important. So here you have the confidence that if anything did happen in this world where, again, the same malware that turns things pink, occurs in this environment, you can, of course, have the assurances that cast iron guarantee, get out of jail free card, that recovery process does work every single time. And this last scenario leads me into my demonstration. So Twilio is more than data protection. Yes, absolutely, it should provide you with the ability to recover your workloads wherever and whenever you need to. But you can also recover or port those applications and data to other environments. That might be for operational reasons. It might be for testing. It could be to minimize service disruption if someone at, I don't know, insert well-known public cloud provider decides to make another, standard non-service affecting change to their block storage service, and it brings down a complete region. Again, in either case, we have known for years, despite pockets of resistance. Hey, look, I've been in this, this IT world for a long time, and I've seen all the all the bubbles come and go in IT. But hybrid cloud is a genuine priority and a challenge, though, for enterprises. And Trilio is here to sit, obviously, at the heart of that solution. So here, of course, we can make backup of workloads. Again, we're a data protection product, so we can protect your applications and data down to the fine level detail of your metadata, and giving you the ability to have those workloads featured elsewhere. It all starts at the backup, but through our native Kubernetes operator, you have the ability to use that data however you need to. You can send those applications and its data to a completely different cloud. It doesn't even have to be the same version or distribution. Trilio gives you that flexibility to transform the data so that orchestrated recovery of that application, the one that we took from on-prem and we recovered to off-prem, makes complete sense on that target cloud. So let's see this in action. So on the, when I click next here, I'll take you through a demonstration. It's pre-recorded. It's one I made genuinely earlier. It's all in real time, because you can tell because I'm terrible at typing. But it's what I'm going to show you on when I showed you this demonstration is an application that runs in Openshift on-prem. And what we're going to do is a backup has already been made, just in the interest of time. And then what we're going to do is we're going to do a recovery using that backup. And we're going to use one of Trilio's tools. It's a disaster recovery plan tool, but obviously it's very, very useful in a migration scenario as well. So whilst it's there for disaster recovery purposes, it gives us a brilliant opportunity to show you that it doesn't always need to be, under a scenario where you've got a gun to your head and you need to make sure everything is all operational, within a couple of minutes. So again, it also works for migrations. So here's the environment. So I've got OpenShift here. It's an OpenShift for 8 environment, and I've got Trilio Vault for Kubernetes installed. And you can see here, I've got a number of new CRDs, custom resource definitions I can use. I've also got a second cluster, my Google Kubernetes engine cluster. And here you can see my absolutely terrible typing. This also has a Trilio Vault for Kubernetes operator installed. Again, you can deploy us on any CNCF based clouds, whether it's one of the public cloud players or it's your own based installation of Kubernetes. And it gives you this rich user interface. Again, we can drive this through the command line. I also show you that's what the red and the blue screens are there as well. And so this user interface discovers your workloads that you as a user has access to. Those tiles are namespace representations, and you can also go inside and actually view the applications that run within these namespaces. And at a glance, you can see your backups that have been created, and from that interface, you can easily create backups and do recoveries as well. Now, in my OpenShift environment, I have a small application. It's a 3-node front-end service with a MySQL server at the back end with a PVC. And in my Google Cloud, which is the blue interface at the bottom there, I'm going to do a recovery into the OCP restore namespace. That I've created that namespace. I've got access to that particular namespace. Important that you've got right access to into these things. And there's nothing in there at the moment. So what we're going to do here is, first of all, set up the target. So a target is, where am I going to store my backups? Remember, we support S3 and NFS targets. This is what we're talking about. And in this case, it's actually an AWS S3 based target. So full multi-cloud on display here. But the key thing here is I've got the same target in both my clouds. In other words, my OpenShift cluster where my backup was taken, and the data is stored, my Google Cloud can also see that same data. And I've created a backup here, which I'm just viewing into the user interface. I can view all the metadata as part of that particular backup of this particular application. Now, in my Google cluster, if I click on this, I have, again, I've got a few namespaces available, but I'm going to do a recovery into that OCP restore namespaces. There's no applications running there at the moment. I showed you that on the command line with my kubectl get PO, PVC. And so that's where I'm going to do the recovery. And to do this, I am going to use the disaster recovery plan tool. Again, it's used under duress, but certainly it can be used for migration scenarios as well. So I'm going to call this a migration restore plan. So that's the name I'm giving this a particular step. And what I'm doing is I'm browsing the target that both of these clusters have access to. And I can see the fact that I've got my backup available on this particular target. And I'm just going to verify this particular backup. So again, I'm showing you that we can drive this from the command line if you prefer. See, I did a kubectl get backups, or because it's OpenShift, I can do OC get backups. I can view my backup plans, and you can see that backup plan matches the backup plan that is on the screen on the left. And I use that backup plan to create that migration backup one backup. So I've selected this as part of my step, and I'm following the wizard. And this brings me onto a screen now where I have a great flexibility in terms of recovery. So I've just chosen the OCP restore namespace on my Google cluster. This is all happening on the Google cluster here. I've got some OpenShift things that don't make sense on Google. Remember I said we support transformations? I'm getting rid of some of the OpenShift specific things, and certainly I'm going to remove the OpenShift storage service from this particular backup. Don't forget, we capture a lot of details. We want to put things back the way they were, but when it comes to doing a transformation or a migration to another cloud, we have to say, don't use this particular storage class, use this other one that we have available to us. So in this case, I'm adding a transformation. I've got my persistent volume claim that would have originally created the under the OCS-based storage. And in this case, I need to use Google's. So I'm just checking the storage classes over in Google. I can see I've got this standard RWO-based block storage here. And I'm literally very easily saying, when you go to create this persistent volume claim, just create it on this particular storage class. And so once those transformations are in place, I say very simple to do, I can click execute. Now, before I do that, I just want to validate the fact that we are, and recap, we are taking a backup plan called OCP migration. It was a namespace backup, and I'm going to send it to the OCP restore namespace on my Google cluster that nothing was running there. So to prove this, let's just jump over to my Google console, and you can see here I've got a couple of pods that are in place. So how we do things at Trillio as part of Trillio Vault for Kubernetes is we spin up pods to achieve these particular tasks. So it's very, obviously it's very Kubernetes friendly. And so to achieve this migration, we will spin up a pod in this particular namespace on Google. It will do a validation that the target, the backup target has all the right information, it's got all the right files, and we can get access to it. And then we go through the process of doing that recovery. And in this case, we do the data recovery first. So we're going to create that persistent volume claim first. And we do that with a data mover pod. It runs a kube job. And in that pod running right now, it's accessing that target. It's seeing there's a qcow2 file in there. It's asking the Google Kubernetes engine for a persistent volume claim using that standard RWO based storage class. And it's populating that PVC with this information from this qcow2 file. It doesn't take long. It takes about a minute. So it's just about to wrap up. So hopefully there's no awkward silences as we wait for that particular step to complete. Like I said, this is all genuinely captured all in real time. And then what happens once the data has been recovered, we do the meta mover piece. And the meta mover at this point, this meta mover pod, is essentially an orchestrator. We've got all the details. We know all about your application. We're just going to tell Kubernetes, go and recreate this application. And as you can see here, as the information, zooms down the console, we can see the fact that it's deployed our front-end application, our MySQL server, and the restore, that migration from on-prem OpenShift to Google has now completed. So let's just verify that. So there was nothing running there before. So we've now got our 3-node front end or MySQL server. We've got a persistent volume claim there, and it matches what we had running in our OpenShift cluster. So where we have those 3-node front ends, the MySQL server, and the persistent volume claim that was created on that particular storage class. Obviously, we've now got, obviously that storage class never existed on Google, so we've now got that persistent volume claim created on the right storage class. Again, very simple to do that. So, in summary, I should click next. There we go. And so the key takeaway points that we get from this. So, porting applications to the cloud obviously involves more than just application redevelopment. I introduced you to obviously the early days of human existence. And of course, we've got to a stage now where applications are highly complex and require a cloud platform to operate and scale. We've also just touched on the fact that obviously reorganizing teams into well-documented DevOps and GitOps roles help align to advantages of the cloud. Not a requirement. All this is, everything we talk about here is all about efficiencies. This is about making sure you go that extra 5-10% further into your journey into cloud. But utilizing cloud-native tools such as Trillio for Kubernetes, of course, they're designed for the cloud. They're designed to fit with how you should work with the cloud. We're not dictating you that you stop what you're doing and have to change gears to perform a backup and recovery. You should just be able to tell Kubernetes, just go and protect this for me, and we'll protect it. That gives you complete control over your applications and data. And when we say complete control, you've always had complete control over your actual deployed applications and data. What we're saying here is you have control of your backups, the data protection, and how you want to utilize that data so it improves on how you would consume those cloud platforms. And then in our demonstration that I just showed you now, I showed a simple process of recovering and migrating that application from that OpenShift on-prem to Google using the notion of our operator, the natural workflows. Even though I use the user interface, absolutely, you can take this to the command line. I could show you the YAML that was created. It's incredibly simple to actually just say to Kubernetes, go and do a restore. Here are those transformations in that same YAML, and just say kubectl apply on that Google Cloud, and it would have just done all that automatically without having to point and click as well, if that's the way you want to go. And lastly, when Trillio for Kubernetes is used for day 0 and day 1, so further down into the chain, you recognize the fact that backup and recovery is just the tip of the iceberg. Taking advantage of the features of an operator from Trillio for Kubernetes gives you much more flexibility on how you could consume your cloud. So thank you very much, and hopefully we've got some questions that I can answer now.
All right. Yes. Thank you, Kevin. Let's look at some questions. We've got a lot of good ones already in. And a reminder to everyone, keep those coming and we'll get to as many as we can. We've got first question is, can I selectively restore just my persistent volumes?
Yeah, absolutely. So when it comes to Trillio, we are... You can pick and choose what you want to recover. So obviously the standard principle is a backup is good as the recovery. Obviously we have all that information which allows you to do a recovery of everything as part of that backup. But we support a full range of inclusions and exclusions and the ability to recover just that data. So it lends itself well to scenarios where you have a third-party tool orchestrating your applications. There isn't an overriding urgent need to protect those particular workloads, but the orchestrated deployment, the application relies on accurate data. And in such a way, you could have your orchestrator, happily scaling out your front end applications and then orchestrate the recovery of that data and have that as a whole encompassing workflow that fulfills that particular recovery. So yeah, we can. The answer is yes.
Okay. And Kevin, there is a question from Tom that you can take a look at. I think we need a little more clarification about that.
I think I understand. Yeah. So there's one here. So so let me just see. This is about archiving. So secondary tasks in terms of backups. So in terms of Twilio supports archival in terms of retention. So you are able to have long-term retention of your backups. Now, what we don't do currently is archive that to secondary storage. So I think that's what the ask is there. Our tool currently, as it stands today, allows you to keep long-time archival backups. So you can set retention policies for, keep your last, monthlies, create on the 28th of the month, keep them for 7 years if you so desire. But that said, whilst we don't move that data ourselves currently as part of the actual workflow, that data is completely accessible. Again, going back to our open universal backup schema, we're writing out backups to some storage. That storage is accessible. That storage is also accessible to other tools, which you may point at those literally files and folders to then perform those archival tasks. So there's a number of ways to certainly tackle that archiving request.
All right. Thank you, Kevin. I know we're getting a little close on time. Let's get one more in here. What's more important when it comes to porting applications to the to be cloud native, reorganizing people into the right teams or the tools that they use?
Yeah. Okay. Yeah. I don't think they're really the only answers. I think the important thing is an understanding of the capability or the capabilities of the cloud, and I would argue that certainly begins with people. I've been in so many conversations and really large cloud transformation projects, and the topic of backup sees us go up against traditional backup vendors. But it's a disconnect in infrastructure, IT, and the front end goals of the project itself. So, seeing cloud data protection tools as more than backup and recovery, for the sole purpose of DR or data focused recovery, doesn't do that cloud migration project any justice. Are people successfully consuming the cloud without reorganizing or their departments, and I mean tribes of DevOps folk? Absolutely. But would people benefit from immediate greater efficiency if they realized that tools such as Twilio Kubernetes has been engineered so you can have workflows that will give you immediate great benefits and immediate great efficiencies. So whilst I don't think there's there's a single answer, and I don't think it's they're the only two answers. Obviously, it's a combination of both, but I think there's more immediate benefits from having the right tools in place, and the people then just become far more efficient.
All right, and I said that one more, but if I could just get one more question in, because security implications are always top of mind. And this question is, you talked about malware and infected backups. Do you provide tools to scan your backups?
Currently, we don't. But remember that I probably talk probably too many times, or certainly too emphatically, about our Open Universal Backup Schema. That Open Universal Backup Schema, the format of those files is QCOW2 files. Full open source. It means all that data is completely yours. And I guess kind of tying into that archival question, and the reason why I have full confidence you can always archive your backups created by Trilio, is the fact that that data is always accessible. And so that QCOW2 format, it's not proprietary, it's not owned by Trilio, but plenty of tools exist. So you can bring your own tools to auto scan those backups. You can have it as part of the workflow. You can literally have it so that when you create a backup using Trilio for Kubernetes, you can auto scan. It's just not a tool that we have at the moment. We're investigating how we can achieve that as part of a workflow from Trilio. But bring your own tools. Absolutely. You've got full access to your own backups.
All right. Well, with that, I'm going to stop at questions and actually hand it back over to you, Kevin, for some next information.
Thank you very much. So yeah, if you are interested, obviously, using and trying Trilio for Kubernetes, I reiterate, we're fully CNCF compatible. You can install it however you need to. We have a whole ecosystem and documentation around how we can incorporate backup and recovery of many databases and database-like services, and we'll do this across any cloud platform. And so if you visited Trilio.io today, take a look, and you can certainly see how easy it is to install our operator today. So yeah, thank you very much for your time, everyone.
And thank you, Kevin, for taking us through all that information and the demo and covering all those questions. Special thanks to Trilio for making this webinar possible today. And for our audience, we want to thank you for taking the time to attend this session. Quick reminders, the winner of our contest is being posted in the attendee chat. Congrats to our winner. We'll be in touch in the community on following up for getting your shipping information. Also, take a look at those resources before we finish up. You can get some more information there. And with that, I want to remind everyone, take a look at our event calendar. That's the icon at the far left of the console to see our next events coming down to you. With that, thank you for attending. Have a great day. And until the next session, stay safe and keep it spicy. Take care, everyone.